What if I told you that in just very few minutes, I could help you understand and know how to answer questions like, for what values of x is f of x greater than 0? For what values of x is f of x greater than g of x? For what values of x is f of x increasing? And all questions like that. If you don't believe me, stay with me for a few minutes because hi, I'm Mudinda and I'm here to help you understand maths better for free. Today we're going to be looking at graph interpretation for grades 10, 11 and 12. We'll be translating complicated sounding maths to simple English. Let's get started. In part 1, what does it mean when a question says, for what values of x is f of x greater than 0? See, grade 11s and 12s, this just means where is the graph above the x-axis? So anytime you hear the question, for what values of x is f of x greater than 0, they're just asking you where on this Cartesian plane do you see the graph being above the x-axis? Let's explain this using some examples. Remember, the x-axis is this little guy over here. This line is the x-axis. So if we had this graph, and as you can see, it has an x-intercept at -1 and another one at 3, and the question was, for what values of x is f of x greater than 0? Like we said, that just means where's the graph above the x-axis? Now if you look at this graph, that would be this region here, as well as this region there. Those are the two regions of this graph that are above the x-axis. This region over here is below the x-axis. So the answer is this region and that region. But that's the answer in English. Let's take it back to the maths. See, this region over here, if you think about it, is everything to the left of -1. That's what represents this region. But to the left of -1 is numbers like -2, -3, and -4, and so on. And those are numbers that are less than -1. So to represent this region mathematically, we say all x values that are less than -1. This region here is everything to the right of 3. And to the right of 3 is numbers like 4, 5, 6, and so on. Numbers that are bigger than 3. So we can represent this region by saying where x is bigger than 3. It is all the x values smaller than -1 and all x values bigger than 3 where we find that this graph is above the x-axis. Between -1 and 3, the graph is actually below the x-axis, and that's not what we're interested in. Great, I hope this makes sense. Let's look at another example. For what values of f of x is f of x greater than 0 here? See, here, the graph is above the x-axis on this region, here. Now, because this is one connected region, this is between -5 and 1, you answer it by saying x is less than 1 but bigger than -5. We only do this when the region we're interested in is one connected region. Unlike here, where we had two disconnected regions, then we would say one region or the other region. Now mind you, in maths, you can only write a statement like this if you put less than and less than here. That's the only time it actually makes sense. So you will always actually write it like this, as long as it's one connected region. Let's look at some more examples. For what values of x is f of x less than 0 in this example? And let's say that here the x-intercept was 1 and here the x-intercept was 3. When it says for what values of x is f of x less than 0, like you guessed it, that means where's the graph below the x-axis? Now, in our case, the graph is below the x-axis here in this region. And that region is actually between 1 and 3. So our answer to this question will be x values that are between 1 and 3. In other words, less than 1 and bigger than 3. Like I said, you'll always put less than and less than there to express this. What about in this example? For what values of x is f of x greater than 0? It's a hyperbola. Feel free to pause the video and think about it and answer first before you see what the actual answer is. But you see, since the hyperbola has two little regions, we need to inspect both those regions. Let's start with this little guy here. Which part of this guy is above the x-axis? Because remember, this means where's the graph above the x-axis? Well, this little guy seems to be above the x-axis here. And remember, that's all values of x that are to the left of minus 3. So one of our answers is x less than minus 3. The rest of this half is below the x-axis, which is not what we're interested in. What about on this half? Well, on that half, the graph is above the x-axis all the time. How do we identify that half? Well, remember that this graph keeps going closer and closer to this asymptote over here, but it just never touches it. So in fact, this region is everything to the right of this asymptote. The asymptote is x is equal to 2. So everywhere to the right of 2, we're seeing the graph being above the x-axis, as well as everywhere to the left of minus 3, we're seeing the graph to be above the x-axis. Here's another one, an exponential graph. For what values of x is f of x greater than 0? That means where's the graph above the x-axis? That's here. That's where it's above. And that is actually everything to the right of 3. So the answer to this is x values bigger than 3. Smaller than 3 x values, we're finding that the graph is below the x-axis. Great, I hope this helps. Let's talk a little bit about points of intersection. We spoke about points of intersection in grade 10 as well. Remember that these are the points where two graphs meet. To determine a point of intersection, you must equate the two graphs' equations. When you do that, that will give you the x values of the points of intersection. You will then take those x values and insert each of them into either one of the two equations. That's how you find points of intersection. You equate the equations of the two graphs, and that will give you the x values of the points of intersection. You then pick one of the equations to insert the x values of the points of intersection, and that will give you the y values of the points of intersection. Let's do that in this example where we're given f of x and g of x, two different functions. And we're being asked to determine For us to determine the points of intersection, like we said, we would equate the two graphs. F of x is equal to g of x. Now, f of x is x squared minus 4x minus 5, while g of x is negative x minus 5. Since this is quadratic, let's move everything to one side. So minus 4x and plus x, minus 5 and plus 5 equals to 0. So now we have x squared minus 3x, and this becomes 0 is equal to 0. We take out a common factor of x, and we're left with x minus 3 is equal to 0. So therefore, x is either 0 or x minus 3 is 0. In other words, or x is 3. Now, these are the two x values of our points of intersection. You then pick one of your equations here and work with it to find the y values of the points of intersection. Now, if you're lazy like me, you're just going to pick the easier one, right? Y is equal to negative x minus 5. So in this case, y is equal to negative 0 minus 5, meaning y is negative 5. So one of the points of intersection of this graph is an x value of 0 and a y value of minus 5. Another point of intersection, we can find its y value by plugging in 3 in place of x here. So negative 3 minus 5, which means y is equal to negative 8. So another point of intersection between these two graphs is an x value of 3 and a y value of minus 5. Now, for your convenience, I have actually drawn these two graphs on Desmos. If you have a look here, the red graph is x squared minus 4x minus 5, and the blue graph is negative x minus 5. Now, as you can see, at 0 and minus 5, the two graphs meet. In other words, it's a point of intersection. They also meet at 3 and minus 8. Those are the 2 points of intersection that we found. As you can see here, 0 to negative 5 and 3 to negative 8 is the 2 points of intersection that we found. Why am I bringing this up? You may be wondering. I want us to talk about for which values of x is f of x greater than g of x, and points of intersection are very important for this part. You will have noticed that in the previous section, where we spoke about for what values of x is f of x greater than 0, and we said that means where the graph is above the x-axis, the x-intercepts were the critical points. Have a look here. It is to the right of the x-intercept and to the left of this x-intercept where this question is being answered. Now, for this kind of question, you'll notice that the points of intersection are important. But let's decode it. Let's translate this from maths to English. When a question says, for what values of x is f of x greater than g of x, that simply means, on this Cartesian plane, where's the f graph above the g graph? That's all it means. Let's look at some examples here. If you have a look at this first example here, we've got f of x, the blue parabola graph. We've got g of x, the pink straight line graph. And the question is, for what values of x is f of x greater than g of x? That means where on this Cartesian plane is the blue graph above the pink graph? If you have a look at this region here that I'm circling, you'll notice it fits the criteria. Here, the blue graph is above the pink graph. Another region where that happens is here. Here, again, the blue graph is up here and the pink graph is down there. This region is everything to the left of this point of intersection. And the x value at this point of intersection is -1. In other words, here we have -1. And so this is now everything to the left of -1. So in other words, all x values that are less than -1, we observe the f graph being above the g graph there. This region is everything to the right of this point of intersection. And remember, this point of intersection has an x value of 4. And so all x values bigger than 4, we also observe the f graph being above the g graph. Since it's two disconnected regions, I'd say or there. Now mind you, between -1 and 4, if you zoom in on that section, you will notice immediately that the pink graph is above the blue graph there. We're not interested in that region. The question is asking us for where the blue graph is above the pink graph. I hope this makes sense. Let's look at more examples. Here, question again now says, for what values of x is f of x less than g of x? That means where's the f graph below the g graph? Now, I haven't put any colors here because I want you to, do some tougher questions without any dead giveaways, since this is how it'll be in your exam. See, the f graph is the parabola, this guy. The g graph is the straight line, this guy. And we're being asked, where's the f graph below the g graph? Well, you would notice that that's actually here in this region here. That's where we're noticing the parabola being below the straight line. Now, that region is between these 2 points of intersection. This point of intersection has an x value of -4. So here we have -4, and this one has an x value of -1. So it is between -4 and -1 that we find the f graph being below the g graph. So x between -4 and -1. Great, I hope this makes sense. Here's another example, asked a bit differently. When a question says, for what values of x is f of x minus g of x equal to 0? Think about the fact that this can be rearranged. We can move the minus g of x to the other side of the equation so that we now have f of x is equal to g of x. But what does this mean? Where is f of x equal to g of x? Well, we said that's where the points of intersection are. So it is actually here and here. In other words, it's when x is -1 and when x is 3 that f of x is equal to g of x. Those are the values of x for which the two graphs are equal. So our answer is x is equal to -1 or where x is equal to 3. That's where f of x is equal to g of x. Those are the x values for which f of x is equal to g of x. Here we're asked, for what values of x is f of x minus g of x greater than 0? Well, again, you can move this g of x to the other side. So what this question is actually asking you is, where is f of x greater than g of x? And that just means where the f graph is above the g graph. Let's say the f graph was this parabola, the g graph was this straight line. Here in this region, we find the f graph being above the g graph. The parabola is above the straight line. That's between -1 and 3. So to answer this, we'd say x between -1 and 3. Great! I hope this is making. Now, up next, grade 11s and 12s, let's talk about this question. For what values of x is f of x times g of x greater than 0? What the heck does this even mean, you may have wondered? Well, matriculants, remember that it is only when you multiply a positive number with another positive number that you would get a positive result, a greater than 0 result. Or when you multiply a negative number with another negative number, that's when you would get a positive result, a result that is greater than 0. So that said, what this question means is we're just looking for the parts of the Cartesian plane where both f and g are positive. What does it mean when we say a graph is positive again? That means it's above the x-axis. Remember we said f of x is greater than 0. In other words, f of x is positive just means above the x-axis. So what this is telling us is we're just looking for where both f and g are above the x-axis, okay? Or where both are below the x-axis. That's all we're looking for here. Let's look at some examples before we talk about this part. Say we were given these two graphs here. Say that this was f of x, this was g of x. And we were asked, for what values of x is f of x times g of x greater than 0? That's just asking us for where both graphs are above the x-axis or where both graphs are below the x-axis. If you have a look at this region here, this does not work. Here, the parabola is above the x-axis and the straight line is below, right? Now, if you have a look, say, somewhere here as well, between -5 and 1, now the straight line's above the x-axis and the parabola is below the x-axis. But the minute you pass an x value of 1, you will notice that now both the graphs are above the x-axis. So it is everything to the right of 1 that we observe both graphs being above the x-axis. To the left of 1, it's either one's above and the other's below or the other way around. For a question like this, it is therefore very important to take note of the x-intercepts, because we're looking for where graphs are either positive or negative. So the x-intercepts are important here of both graphs. Here's another one. We're given two graphs here. Say the parabola was f of x and the straight line was g of x. For what values of x is f of x divided by g of x greater than 0? Much like multiplication, it's only when you have a positive divided by a positive that you get a positive, or when you have a negative divided by a negative that you get a positive. And so here, we're again just looking for where both graphs are above the x-axis or where both graphs are below the x-axis. We have some critical points 3, 2, and 4 here. What's going on to the left of 3? Seems like both graphs are above the x-axis there. So great, one of our solutions is x values that are less than -3. What's going on between -3 and 2? What's going on there? It looks to me like here the parabola is below the x-axis but the straight line's above the x-axis. That won't work. What about between 2 and 4? What's going on here? If you look between 2 and 4, both graphs are actually below the x-axis. Here's the straight line, it's below the x-axis. Here's the parabola, it's below the x-axis between 2 and 4. Remember that for this question, we're not concerned about which graph is above which. This simply means where both graphs are above the x-axis. So the region x between 2 and 4 actually works for us. What about the region after 4? Does this work? No. Here, the parabola is above and the straight line is below. So the only possible answers are x less than 3, because everything to the left of 3, we've noticed both graphs being above the x-axis, and x between 2 and 4, because again here we now notice them both being below the x-axis. This second part says, for what values of x is f of x times g of x less than 0 or negative? The only time in maths that the product, in other words, the multiplication of two things, is negative is when one of them is positive and the other is negative. Plus times minus gives us less than 0, gives us a negative. Minus times plus gives us a negative. In other words, when you're asked for what values of x is f of x times g of x less than 0, we're looking for where one graph is above the x-axis and the other is below. One graph is positive and the other is negative. Let's look at some examples here. This question says, for what values of x is f of x times g of x less than 0? Say the parabola was f of x and the straight line graph was g of x. That would mean we're looking for where one is above and the other is below. See, to the left of this negative 3 point, you will notice that our straight line graph is above the x-axis, but our parabola is below the x-axis. And that's exactly what we're looking for. So x less than 3 is one of the answers. What about between minus 1 and minus 3? What's going on there? Well, there, both graphs are above the x-axis, and that's not going to work for us. We're not interested in that. What about between minus 1 and 1? What's going on there? There, the parabola is above the x-axis, and the straight line graph is below the x-axis. That works. So between minus 1 and 1 works. What's happening to the right of 1? Both graphs are below the x-axis. That doesn't work. One more example here. For what values of x is f of x over g of x less than 0? Well, by now you know that that's the same as multiplying, so we're still looking for where one is above and the other is below. Everything to the left of minus 1 seems to satisfy our condition, because there the parabola is above and the straight line is below. So x values less than negative 1 work. Now what about between negative 1 and 3? Unfortunately there, both the straight line and the parabola are below the x-axis. That doesn't work for us. What about between 3 and 6? Here, the parabola is below and the straight line is above the x-axis. So that works for us because that's what we're looking for. X values between 3 and 6 work. What about x values after 6? Here, both graphs are above the x-axis, and so that does not work for us. For what values of x is f of x increasing or decreasing? To answer this, let's talk about increasing versus decreasing functions. You will have learned in earlier grades that a upward sloping straight line graph like this one is an increasing graph. A downward sloping straight line graph is a decreasing graph. The reason behind that is when we say a graph is increasing, we mean that if you were to move along the graph, you would notice that when x increases, y increases as well. So for example, here in this blue graph, right? Let's move rightwards. Let's move maybe from this blue point here to this green point there. See, as you move rightwards, you're also moving upwards, right? Blue to green is rightwards. It's a rightward movement, isn't it? But it's also an upward movement, right? And rightward movements are increases in x. Upward movements are increases in x as well. Yo, I lied to you here. An increasing graph is one where, okay, let me do it this way. An increasing graph is one where as x increases, y increases as well. Okay, so you can see on this graph that as you move rightward along the graph, you're also moving upwards. In other words, as x increases on this graph, y increases as well. That's why we call it an increasing function. But for a decreasing function, if you were to move rightward along the graph, like if we started here on a left point and moved here towards a right point, I want you to notice that yes, we're moving rightwards. We're moving from left to right, but we're also moving downwards. Remember, moving rightward is an increase in x. So as x increases here, y decreases. So this is actually a decreasing graph. Okay, that's what it means. But you don't have to stress yourself too much about that. Just know that if a graph is upward sloping like this, it's increasing. If a graph is downward sloping like that, it's decreasing. But now what happens with a parabola? When one half of a, well, with a parabola, one half is increasing and the other half is decreasing. Let's have a look. After I edit my note here. Okay. If you look at this graph here and cut it in half right at the turning point, you will notice that this side is a decreasing function. It's sloping downwards. This half is an increasing function. It's sloping upwards. If you look here, cut it right through the turning point. This half is sloping upwards. It's increasing. This half is sloping downwards. It's a decreasing graph. One half of a parabola is increasing and the other half is decreasing. Just keep in mind, increasing means sloping that way. Decreasing means sloping this way. How do we answer the question though? For what values of x is f of x increasing? Well, have a look at this example here. What's important to us is our turning point. For this graph here, if we were asked for what values of x is increasing, well, this side here is downward sloping, it's decreasing. But this side here is upward sloping, it's increasing. Remember the shapes of upward sloping and downward sloping? Upward, downward, okay? The side that is upward is this one. This is downwards. So how do we represent this side that is upward sloping, the increasing side? Well, it's everything to the right of the turning point. So our answer is all x values bigger than 2. 2 is the x value of the turning point. So for this question, it's actually very important, the turning point. How do we answer this one? For what values of x here is this f of x graph increasing? Where is it upward sloping? I would say it's this half, which is everything to the left of the turning point. So all x values less than 1. Here, for what values of x is f of x decreasing? This side is the one that is sloping downwards or decreasing. And that side is everything to the left of the turning point. So all x values less than -2. Last one. For what values of x is f of x decreasing here? This side, where the graph is sloping downwards. And that's everything to the right of the turning point. So all x values that are bigger than -1. Grade 11s, matriculants, I told you I could help you understand how these questions work. See you in the next video where we'll be talking about the domain and range, and the next one where we talk about translations and reflections, and then we do past paper examples.